Good evening. So we were asked to talk about the impact of data path cycle speed on CPU performance. Okay, so with that, we first have to introduce the CPU data path and clock cycle. So what is the CPU data path? So it based on three paths here. So it's with the fetch, the decode, and the execute. With the fetch, the CPU places this address on the address bars and fetches the instructions via the data bars. With the decode, it identifies the operation to be performed. Example, we have the arithmetic, we have the logical, we have the data transfer. With the execute, the CPU performs the operation specified by the instructions. So with there, we now move to the stages of a basic cycle. The stage of the basic cycle, we have a typical instructions in the CPU which goes through several pages. So we have the instruction fetch, which we spoke about earlier on, and with that it fetches the instructions from the memory. We have the instruction decode, which that one also it decodes the instructions to determine the operation, sorry. And with the execute, the operation is performed, which I spoke about by giving examples like the arithmetic and the operation by the alu. So we now move on to how clock speed affects CPU performance. So one, the clock speed is measured in hertz, which we all know, and it determines how quickly the CPU can complete a cycle. Secondly, it has a faster clock speed, more cycles per second, more instructions executed per second. Yeah, so I'll just move on to the next one because it's a lot here. So in conclusion, we'll conclude by saying with the faster data path cycle, it gives better performance. And the speed of the data path cycle, which is the clock cycle, is a key determinant of CPU performance. Faster cycles mean lower latency, higher throughput, and ultimately better CPU performance. Other factors like pipelining and parallelism also contribute to overall performance. Visual, a summary graphic showing the relationship between clock speed, latency, and throughput with arrows indicating the performance improvements as clock speed increases. So here are some diagrams which shows how you start before you move to the fetch. After the fetch, you go to the decode and the register fetch, and you come downwards. And a different diagram here also talking about the CPU data path. Yes, thank you.